Okay, so now we're going to look at the rock sections and be able to predict and sequence things that are happening into that rock section. That's called relative dating. So our essential question today is, how do we know which layer of rock is older when the plates move the rock? So this goes with learning target 27, be able to identify, describe, and determine the sequence of major events in Earth's geological history by examining rock layers. So you'll be able to look at a section of rock and sequence and tell what happened first, second, and third based on the information that we learned today. Okay, so the law of superposition states that in undisturbed layers of rocks, the oldest rocks are found on the bottom and the younger ones on top. Sediments accumulate in horizontal beds, becoming layers. The first layer is always on the bottom. So if you take a look at this picture down here, if sediments are laid down horizontally because they haven't been disturbed, the oldest layer will always be put down first, and it's going to be on the bottom. The picture to the right shows you how you've got different layers of rocks. You can tell the different layers by the different colors. Okay, these oldest layers are the ones at the bottom. The youngest ones were put down on the top. Okay, so from this one we can show. Okay, so this is a very similar picture. You can see the different colors of rocks and the different layers. So this is how that area formed. The oldest layer was put down first. Then another layer was put down that's younger than the older layer, and that's how this area got created. So that is the law of superposition. The oldest layer of the rock is always going to be found on the bottom. The youngest layer will be found on the top. And that's pretty important when we try to start sequencing and talking about what happened first, second, and third to a rock section from plate movement. When we look at rock sections, we look at what's called relative age. This is the age in comparison to the age of other things, which we call sequencing. So, for example, if you take a look at this rock section, we've got the oldest layers obviously on the bottom. These layers are younger. The one on the top is the youngest. If we find fossils in this layer, okay, then we know that this layer and this rock and this fossil, this rock and this fossil formed at roughly around the same time. They were around during the same time. Okay, now we can find the same fossil in an earlier rock section, same fossil. So then what we do is we take the relative age. We say, okay, if this fossil, even though it's found in two layers, we're going to look at the bottom layer, and we're going to look at and see how old it is. If we know this layer is 385 million years old, then we know that the layer below it that contains the fossil, this layer right here, okay, that contains this fossil, has to be older than 385 million years. That's what we call relative age. We're not going to look at this fossil because it was around at a younger time frame. We look at the oldest possible time. So the fossil we find in the oldest layer, that's how we're going to know how old that fossil is. Same thing here with this fossil. Since we found it in this rock area, even though we found another one in this one, this rock area is younger than this one, we're going to date this fossil. And if we know that this rock section right here is about 355 million years old, then we're going to say that's how old this fossil was. And that's where this living thing lived, about 355 million years ago. Whereas this fossil lived past 385 million years ago. So that's what it means to talk about relative age. It's comparing the age to other things. Okay, so when we start to date rock sections and figure out what came first, second, and third, we've got to look at what's called unconformities. There are three types of unconformities. The first one we're going to talk about is an angular unconformity. This means that horizontal layers that have been laid down are tilted or uplifted. So if we take a look at this picture, okay, this is the layers that used to have been put down horizontally. They get tilted. And if they get tilted, then that kind of changes, and that can happen during plate tectonics. And then if some of the layers get weathered or erode, we lose some of that. So here's an example of an angular unconformity. So the layers get put down horizontally, just like you saw before. And if it was undisturbed, it would be left like this. However, through plate movement, that's a magma intrusion, by the way, that you're seeing. By plate movement, it tilted that rock section. And then what happened is that part of that kind of peachy color got eroded, and then another layer got laid down upon it. So right there, we call that an unconformity, because there's an area that got eroded in that rock layer that we did not get to see, that we don't know where it went. So that's what an angular unconformity is, when rock layers are laid down horizontally, and then they get tilted by plate movement. Once they get tilted, some of the layers get eroded and moved away. They get broken down to pieces and moved. And when that happens, we say that's the unconformity. That's a gap in our rock record. And that's what an unconformity is. It's pretty much a gap in our rock record, because we know that this peach section probably went all the way across, but we're missing some of it, so it's a gap. Okay, a disconformity is when horizontal layers are put down and only one layer is eroded. So, or a couple layers can be eroded. So these layers have been put down horizontally, and then this squiggly line, that represents erosion. So that means that there's a layer here that is missing. It's been eroded. So that's a disconformity. Okay, we'll play this and show you. Layers are put down horizontally. Now they're getting eroded. That's what it's showing you with the squiggly lines. Once one layer gets eroded, then new layers can be laid down upon it. So if we were to date this, excuse me, and to sequence this rock section, we would say layers 1, 2, 3, and 4 were deposited, put down first. Then layers 5 through 14 were deposited and eroded. That's how many layers were eroded. Then layers 15 and 16 were deposited down. The last type of unconformity is called a nonconformity. This is where metamorphic or igneous rocks are uplifted and eroded, sedimentary rocks are put down. So pretty much this area right here is an igneous rock. It's been eroded, that's what this dark line represents, and then sedimentary rocks were put down above it. In this picture too, you can see the same thing. The dark rock is the igneous rock. There's a layer right here that's been eroded, that's our gap in our sequencing, and then sedimentary rocks were laid down on top. Now, we also have talked about dike and sills as being magma intrusions, and you're going to see this when we start relatively dating and sequencing rock sections. I just want to remind you, a dike is a vertical magma intrusion that comes through cracks in rocks. This is the dike, and a sill is a horizontal magma intrusion. That's what represented there. Now, that's it for the notes that we have on relative dating and sequencing. The next video that you'll need to watch is how we sequence. I'm going to take you step by step on a practice on how we sequence. You'll need to watch that before you do the practice, and that'll be the next video.